Lesson 82, Evaluating Functions, Domain, and Range. So, 82A, that's where we are now. Evaluating functions. So, remember how we talked about function notation, functions of x. We're going to do some more of those. So, for example, we have f of x, and remember, when we say f of x, we're just giving a function a name. That doesn't mean anything, not truly. And you can name them f, g, h. We skip I and we go to j, k, l, m, n, o, p, all the way around until we get to a. We get back to f, then we would double it. But it's just so you have the ability to talk about more than one function at a time and know which one you're talking about. So f or g or h function, it's just a mechanism for being able to discuss and talk about different functions without getting them confused. So do not let this throw you off. All this means is that for this function, this is what x stands for. So we have f of x equals x squared plus 5. All right, let us say that I don't know, x is equal to 1. So we would make a bucket. We would say f is equal to 1. Function, f is equal to 1. So we would put in our 1 here, plus 5. That's all we're doing. This is just telling us what to sub for. And it's going to say if f is equal to 1, if the function of x is 1. So easy, 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 easy. You just sub it in, and we know that f of 1 is going to be 1 times 1 is 1, plus 5, that's going to equal 6. Done, right? So let's move on to, let's clear this page, to an actual problem, an example problem. So let's 82.1. Let's jump in there. 82.1. I don't know why my pen is jumping around so much. I probably need a new tip. That's probably what it is. Let me see if I can twist it just a little bit. There we go. That might help. All right, so we have if f of x is equal to x squared plus x minus 10. It's supposed to be 0. Find the value when x is equal to 5, or find f of 5. So all we do is we come over here and we say f of 5 equals, we put in our buckets, we put 5 in, and we solve it. And that's supposed to be a 0. So f of 5 is 5 times 5 is 25, plus 5 minus 10, that's 30 minus 10, that equals 20. Easy peasy. That's all there is to it, ladies. Ladies and gents, if there are any gents out there. 82.3. All right, this one's a little bit wonky. I'm sorry, 82.2. I'm skipping ahead of myself. This one is labeled with an H. So if h of x equals this, plus x plus 1, find, I don't know why my pen is messing up so badly. Probably, like I said, I probably need a new tip. I'll have to get a new tip for the next lesson. Find h where x is equal to a squared. This can be any value. And this time, it's another variable, a variable squared at that. So h of x is equal to, remember we put our bucket in, the square stays with the bucket. Don't get confused. Here's another bucket plus 1. So now we drop in our value. I'm sorry, this should be this. All right, that's a 2. All right, so now we say h of a squared equals a squared times a squared is what? It's a to the 4th, right? Because we squared this. All we have to do is multiply these to get this. Plus a squared plus 1. That's as far as we can go. That is it. That's our answer. And this was our answer up here. All right. All right, I'm going to pause and change the tip. All right, let's see if that's any better. I took just a second to knock that out. All right, so pretty easy so far. Let's clear the page. And let's do 82.3. Yeah, that may have helped. We'll just pay attention and see if it's still good. All right, so if f of x equals x squared plus 1, find f of x, plus 2. I touched my hand to the little thing. So this time we have a sentence or a little sentence here, a formula that we're going to drop in. Okay, so find, let's see, f of x plus 2 is going to be x plus 2 plus the squared plus 1, right? So now we know how to do these. There's 2 ways that you can do these. You can do them like this, where you say x plus 2 over x plus 2, right? We say x times x is x squared, and x times 2 is a plus 2x. And then we switch sides, we say 2x and plus 4. And then we combine it. And that's x squared plus 4x plus 4. Or you can use the FOIL method, which is the way that I learned as a kid. Either way, it's going to give you the same answer. I'll just show you here. First, outer, inner, last. Same answer for both, so it doesn't matter. So f of x plus 2 equals x squared plus 4x plus, and we have 4 and a positive 1, so we're just going to go ahead and add those together and make 5. And that would be our answer. Okay. Awesome. Those are pretty easy. Let's see if we have some hard ones. That's it. That's the last for functional notation. So let's clear this page. And let's talk about domain and range. Okay, so domain is going to be basically all of your x values. Okay. And the range is going to be all of the y values. Right? But we speak about the range in terms of f. And we speak about the domain in terms of f. We say the domain of f. And f could be G, H, J, K, whatever. F is the name of your function. Okay? It's the name of your function. So if your function is h of x, then your would be domain of h. Okay? For instance, we have if f of x equals 2x, find the domain and the range of function f. Okay, so we could put anything in there for x, couldn't we? Absolutely anything in there at all, right? So x could be, without even graphing or solving anything, we can say that the domain of f equals the set of all real numbers. All right, I'm going to teach you a shorter way to write all of that. And that is this. The domain, this should be an n, of f equals, here's your little curly bracket, x is a member, we've seen that before, of the set of all real numbers. Right there. That's it. So x is a member of the set of all real numbers. That's all of them. So you can write this really quick. X is a member of this set for this, and that will be fine. So your domain, you'd have to write the domain of f, and you would put these. This is what I'd be looking for. If you want to answer in your GenoPod, I would be looking for this. I'd be looking for the curly bracket, variable x, this, and this. And if, I'm going to have to check your keyboard, but if your keyboard does not make this symbol, just use a capital R, and that'll be okay. Okay? And end it with a curly bracket. All right? So let's continue with the range. What is the range going to be? So if x can be anything, then I think that the range can be anything. Let's graph it and see. Let's make sure. So here's our little graph. We'll go ahead and just knock that out. So if this, let's see, y is equal to 2x. So our slope is 2 over 1. So if x is 0, then y is 0, right? Because if we put a 0 in here times -2, or I'm sorry, times 2, that's going to be 0. Y is going to be equal to 0. So 0, 0. So now we just graph based off of our slope. We go all right, that's not going to be great, but it's going to be close. Up 2 over 1. All right, up 2 and over 1. So that's our line. Not the best drawn line in the world. But our first point is 0, 0. And up 2 over 1. Our second point is going to be 1, 2. And then our next point is going to be 2, 4. Right? So our range for y could be any number. It's in there. It's going to go all the way this way and all the way that way. So it is a set of all real numbers as well. So your range of f is going to be the same thing. It's going to be where only instead of x, it's going to be where y is a member of the set of all real numbers, right? Don't forget your ending bracket. And this was 82.4. All right, so let's clear this. I'm going to try something a little bit different for this one. I'm going to actually try typing since my pen is not doing that great. So 82.5 says that if f of x equals 3, find the domain and range of the function f. Oh, I think that was faster. All right, so I think we'll start using that from now on. I'll start typing my stuff. It looks like it was a little bit neat. You can actually read it, so that's great. Reading it is nice, right? So if f of x is equal to 3, we know that y is equal to 3. And that means that y is going to be at number 3 above the x-axis, regardless of what x equals. Right? We don't even have a variable for x in here. So x doesn't figure in. Y is always going to be 3. So that tells us that the domain of f is going to equal x is a member of the set of all real numbers. That just means that, you know, we're going to have, here's our graph, and y is going to be 3. Let's pretend that's 3 forever and ever and ever. And x is going to be every number on the number line. Y is still going to be at 3. So x is the member of the set of all real numbers. And because range represents y, range of f is going to equal 3. Because we're told right here that y is 3 and y represents the range. So x is going to be your domain values. Y is your range values. That's all that is. Okay? Shall we do 82.6? I'm going to type that too because that seemed to be really, really fast. All right, so 82.6. If the graph, hang on, let me type in 82.6. If the graph of a function is, well, it gives us the name, f is as shown, determine the domain and range of f. Isn't that funny? I can type as fast as I talk, but I can't write as fast as I talk. So my fingertips are faster than my hand. Isn't that crazy? All right, but at least we've solved that little quandary there. Okay, so if the graph of a function f is as shown, determine the domain and range. So here's our graph. This is what we're given. We have this little graph here. Actually, this needs to go up a little bit more. So let me Control-Z that. Let me undo it. Let's bring him down a little bit. Okay. We have these points. We have 2 and 3, 0 and 0, and 3 and 4. And 3 and 4 is filled in. This is the function that we're given. So we have to find the domain of f. And we have to find the range of f. And that's going to be x is a member of the set of real numbers, and that'll be y is a member of the set of real numbers. So you can go ahead and set those up, right? Unless you have a situation like this where y is a static, a single number, and it's a constant value, then you can set this up. You can always erase this if you need to, or you can just get to the bracket and stop there. It's up to you. All right, so let's look and see where our domain is. Our domain is the x values. So our domain is open on the -2 all the way over to 3 where it's closed in. All you do is you bring that down and look at the values on the x-axis. Okay, so what does it remind you of? It reminds you of a conjunction, right? That's what we're going to be doing. This is a conjunction. So in this conjunction, we have x is, this is just going to be x is greater than this circle right here. So x is greater than, and because the circle is open, there's no equal to. So it's just greater than. So x is greater than, that's a negative, let's see, -1, -2, that's -2, right? And x is right here, this is a filled in circle on 3. So x is going to be less than or equal to, because it's filled in, x is less than or equal to 3. So now we need to combine those. So all we need to do to combine, let's rewrite x is less than -3. I find that if you rewrite the one that's greater, the greatest value, then just flip this over, it'll be easier to do the conjunction. So the trick to this is we want to flip it so that there's only one x in the middle, right? So that this actually represents what we're seeing, because this is x, all of this in between here, right? So x is going to be, it's greater than -2. So we're going to make this open v, the open part, face the x. So it faces the x. And now we write -2 on the side, which is the point where the -2 is. The point is facing the -2. And that's how you write your conjunction. You can also see it on here. X is going to be greater than -2, and it's also going to be less than or equal to 3. So we see that conjunction written here and here. It's the same. So for x, the domain of f equals x is a member of the real set of all numbers such that, that's a new term for us, so remember that, that's that straight up and down line that we've been trying to use as an absolute value symbol, but it's not. It's such that -2 is less than x, and x is less than or equal to 3. And that is our domain of f. Okay? Awesome. So now, let's figure out the range. Let's do the range in red so we can see the difference. So our range starts up here at 4, and it's a filled-in circle, and it stops at 0, and that's a filled-in circle. That's our range. So our range is y, right? So our range is such that y, the greatest part, y is less than or equal to 4, right here. But y is also greater than or equal to 0. So y is greater than y. The greater side is always, if it's y is greater, this is the greater side. So it faces the y. Greater than or equal to 0. Right? Do you see that? You have 0 here, and you have 4 here, and y is all those in the middle. It's greater than or equal to, and it's greater than or equal to 0. Right? So that's what we have here. We're just going to such that 0 is less than or equal to y, and y is less than or equal to 4. And that's our domain and our range of f when we are given a graph to look at. All we used was our eyeballs, right, to figure out the domain and the range. We did not have a formula or an equation. So that's how you can use graphing to determine the domain and range of f. You can just look at it and see where it goes. All right, so let's clear this and let's do 82.7. And I'm going to go back to typing because that seemed to work really well for us. I think I'm going to keep using the whole typing thing. So 82.7. Find the domain of the function f of x where it equals, all right, this one's going to be hard for me to type because I don't know how to type this, f minus x, but it is, let me get my black here, under a radical. All right, so find the domain of the function f of x where it equals the square root of 5 minus x. And we know it's a square root because there's no number here. Okay. All right, so here is where we start to bump up against some rules. If it is in an even numbered radical, in this case, this is a 2, because we know if there's no number, it's 2. If it is in an even numbered radical, it cannot be a negative number inside the radical. So that means that it can't be less than 0. So what that means is the least that x can equal is 5, because 5 minus 5 is 0. If we had 5.1, we would have a negative 0.1. If we had 5.0000 anything, it would be negative 0.000 anything. So 5 is where it has to stop. So x has to be less than or equal to 5 with that logic. Let's test that out. What if it's a negative 5? Well, 5 minus a negative 5, that's going to be 10, because the negative will cancel out this negative. Negative 1 times negative 5 is going to be 5 plus 5 equals 10, right? So yeah, that works. That works. That proves true. So this is correct. So we can say that the domain of f equals x is a member of the set of real numbers such that x is less than or equal to 5. Easy peasy. That was a quick one. All right, let's do another one. This is our last one. And I'm going to type as much as I can. Find, whoops, let's put in our number, 82.8. Find the domain of the function g of x equal to, and I'm going to have to draw the rest. All right. And here is another set of rules that we cannot ignore. So what is our rule here? What can x not be? X cannot be 0, right? It can be any other number, but it can't be 0. Because if it's 0, it's indeterminate. Remember our rules of fractions with 0? It cannot be a 0. Okay? Or else it would be indeterminate, and that would not be a real function. So all we have to do is say the domain of the function, or of f, equals x is a member of the set of all real numbers such that x is not equal to 0. Because it could be a negative. We could have a negative fraction. That's fine. So that's fine. We can have a decimal. We could have another fraction, right? We know how to handle that, but we can't handle when x is 0. So this is true. So pay attention to your symbols, your formatting. Remember your rules. Most of your rules are going to center around negatives or zeros. All right? When you pay attention to those and you learn those, you'll get the rest of this correct, because this is mostly just logic and remembering your rules. And that's all we have for lesson 82. I will see you in lesson 83.